Hello students, welcome to Educate. Today we are going to continue with the chapter Gravitation of class 11th physics. We are going to start with gravitational potential energy. So we consider this is Earth, this is center of Earth, and this is a point where there is an object of mass m, and distance of this point from center of Earth is x. Now here at this point, if we calculate the force on the object, so force will be g m m divided by x square. This is force of attraction, right? This is from Newton's law. Now suppose object moves from A to B. So what work will be done? Work done in moving object from A to B through distance dx is dw is equal to f dx. That is f equal to this much, g m divided by x square dx. Now total work done can be found by integrating it. So here we can put the limit. So we can write work done in bringing object from infinity to a point at distance r from center of Earth. Right? Then we can integrate it. So it will become w equal to integration, and limits will be infinity to r, and then we can integrate it. So let's write next step. So it will be w equals infinity to r f dx. So g m divided by x square dx, and if you remember, integration dx upon x power 2 will be x power minus 2 plus 1 divided by minus 2 plus 1, which will be minus 1 upon x. So here it becomes, let's write it as w equal to minus g m and then 1 upon x, limits infinity to r. This will become minus g m 1 upon r minus 1 upon infinity. And if you remember, infinity is very large number. When it divides 1, it will give 0, almost 0. So we have got w equal to minus g m divided by r. This work done equal to potential energy. So we denote it as U. Up to here, is there any problem? No? Now, if body moves from R1 to R2, then change in PE, then change in PE will be, say, delta U. So same thing, we integrate it of limits r1 to r2 gmm divided by x square dx, right? Now same thing we will get. So change in PE, delta PE will be equal to minus GMM and sorry, so GMM here minus 1 upon x r1 to r2, right? So this will become, if you take minus sign outside or just keep there, whatever, GMM, then 1 upon r2 minus 1 upon r1, right? Or GMM 1 upon r1 minus 1 upon r2, right? So now if you assume that here, if this is earth and this one point r1 is here, so r1 will be radius of earth, and suppose this is one point here at height h, so this will r2 will be r plus h if this is h. So then in that case it will become g, here this is change in potential energy, g mm 1 upon r minus 1 upon r plus h. GMM, this is r into r plus h, r plus h minus r will cancel out, and we will be left with GMM into h divided by r into r plus h. Up to here, any problem? Now, here we use some approximation. If h is less than r, then r plus h can be written as r. So here change in potential energy delta U will become GMM h divided by r square. But if you remember, small g is given by gm divided by r square. So here gm upon r square will become small g. So delta U will become mgh. So this is general expression that we use for potential energy. So I think you have understood it fully. Now our next concept is gravitational potential. Gravitational potential. So it is denoted as V, and it is given by U divided by M. So U is minus GMM upon R and this M. So we get minus GM divided by R. So this is gravitational potential. Now further, let's see what is orbital velocity. So orbital velocity. To find orbital velocity, this is Earth. We imagine this path at height h, the Earth surface. Here radius of Earth. This is Earth, right? Here there is satellite of mass m. Mass of Earth is capital M. Now force on satellite. So F gravitational force, let's denote it as F small g equal to G M M divided by R plus H whole square. Any confusion? Newton's law of gravitation. And the centripetal force, say we write it as Fc, will be mv square divided by R plus H. The two forces must be same, and we can write in place of V as V orbital, so that will be better. If we equate the two forces, so Gmm divided by R plus H whole square is equal to mv0 square divided by R plus H, right? One R plus H will cancel out and one M will also cancel out. So we will get V0 square equal to Gm divided by R plus H, or V0 equal to root of Gm divided by R plus H. Here again we use approximation like H is less than R. In that case R plus H will be equal to R. So here our relation will become V0 equal to Gm divided by R. If you remember, small g is given by Gm divided by R square. So if we put that value over here, so this will become root G times R. Now we can put the values. G is 9.8 and R is the radius of Earth, 6400 kilometer. So after evaluation, we will get 7.92 kilometer per second. So this is value of orbital velocity. I think thing is clear. Now let's see next concept, that is escape velocity. What is escape velocity? Its notation, say V escape. So same thing we can do as we have studied in case of gravitational potential energy. We take some points, then work done, we calculate, suppose this distance is dx, up to here say this distance is suppose x, and suppose body is here and mass is m. So in that case, what will be the force? Force will be Gmm divided by x square. Now body is moved to certain distance, so some work will be done. So if body moves through distance dx, then small work done dw is equal to f dx. So dw equal to Gmm divided by x square dx. Now if we want to move the body from surface of Earth to infinity, so that body may escape, so we can put the limit. So w equal to, we can, yes, मैं 2 मिनट में बंद कर रहा हूँ, 2 मिनट. So here w equal to Gmm divided by x square dx, and we put the limits from R to infinity, right? So this will become minus Gmm divided by, Here y minus sign because 1 upon x square integration gives x power minus 1 upon minus 1. So that is why. So here 1 upon x. Then limits are to infinity. If we put the limits, so minus gmm 1 upon infinity minus 1 upon r. So this gives gmm divided by r. So this is value of work done. Now this work done must be equal to kinetic energy. So kinetic energy half mv escape square is gmm divided by r, right? So here mm will cancel out, then ve square equal to 2gm divided by r. But if you remember, small g equal to gm upon r square. So in place of gm we can write gr square. So ve square equal to 2 small g r square divided by capital R square divided by capital R. So ve square equal to 2g r, which gives ve equal to root 2gr. Now if we put the values, then 2 into 9.8 into 6400 into 10 to the power 3 under root. So on evaluation we will get 11.2 into 10 power 3 meter per second. So this is value of escape velocity. Now relation between escape velocity and orbital velocity. So we know v orbital is root gr and v escape is root 2gr. So we can say that ve equal to root 2 times vu. So this is an important relation. I think you have understood. Thank you, Team Educate.